Hello everyone and welcome. This is Jim Kaufman with Rankin Technical College. This video is about moving from our static arrays that we have in our code to using persistent storage in a Mongo database. And this is for our lab 03-01. So we had our in-memory arrays, right? The user array, the bug array, and we could actually, we were doing a lot of testing with Postman, different routes. And if you wanted to add a new user, you could, and that data would be there. If you went ahead and did a get and did your list, you'd see that data. But once you restart your server, that's gone, right? Because that's volatile memory, right? It's just there until we restart. It stays in memory until we restart, and then it's gone. We're actually going to then move, and it's actually synchronous, right? That data's there. It was a defined an array at the top of our file, and so that data was there and ready, and we could access in a synchronous way. Just get me this data, right? Whereas when we move to Mongo database, we have to make a call, right? We have to go over the network to make a call, so we have network latency. So for that, we have to do things a little different, okay? And we're going to actually access it in an asynchronous way so that we don't have to, in our code, we don't want to put ourselves in a position where we make a call and just sit there and wait for it to finish, right? We're going to use some mechanisms so that we can go ahead and continue with our code. And then once that data's back, then comes back and into our application, then we can go ahead and use it, okay? So we're going to kind of use a two-layer strategy with our data. So we're going to have like we've already kind of worked on our API calls from our routes, okay? But what we want to do is we want to really separate our data in our database TypeScript file so that we connect to Atlas there, we execute our queries there, we manage the connections there. We keep that all separate, right? Kind of the separation of concerns concept. And then also if, for some reason we decide to use a different kind of database, right? Maybe we wanted to use an SQL database, or there's other document databases that are similar to Mongo as well that we may want to use, right? And if we decide to do that, we could, we don't have to necessarily change all of our code in our routes, right? Our routes could stay the same. For the most part, we'll have to make some little bit adjustments because we're doing some imports and stuff, but we pretty much keep that, pretty much the same. And then our database layer, which would be our database TypeScript file, would have all of our database related stuff in there. Okay. So our database layer is basically our single source of truth. So it contains all the connection logic and all of our CRUD functions. And from our database TypeScript file, we would return those functions to our routes, okay? And then basically our routes is going to read the request parameters, validate our user input, calls the data access functions, and then sends the JSON responses back. So here's the idea of our data access layer, single source of truth. So core components here of this database TypeScript file. You're basically importing your Mongo client. We're going to have some other imports as well. It'll be a little different than this, but you're importing your Mongo, and then you have some connection logic to do a connect, right? And as you notice, we're using async here. You see the async and await. We'll talk about that a little bit more. And then also we are doing the same async and await for, like, here's an example of find all users, right? So obviously you need to make sure, I'm mentioning this now, we'll talk about this in the future. You need to make sure you have the correct collection that you're accessing, right? But this is basically your function that you're going to call from your routes, right? You're going to call this database. You're going to use modules to call your database TypeScript file, okay? And you're going to call these different functions, all right? And like I said, the best thing about this is that you're keeping all your logic outside of your routes. Okay, and this file will take care of all your CRUD, your different CRUD operations. So the physics of networking, the blocking problem. So there's two different ways to make requests. You can do it using synchronous or asynchronous, right? So synchronous, you basically have to wait until your request completes before any of the other requests can do it, right? So it's a blocking it's a blocking scenario. Okay. The other is asynchronous. It's non-blocking. So you can go ahead and make your database request, and while you're waiting for that to return, other requests, other code can be executed while you're waiting. Okay. So if you recall, Node.js, which is the runtime environment, right? It's not a code, it's not a framework, it's a runtime environment. Node.js is architected to be asynchronous, right? And it utilizes an event-driven, non-blocking I/O model. And so what it does is it processes operations asynchronously through a component called an event loop. So when Node.js performs an I/O operation, like accessing a database or reading a file, etc., it doesn't wait for the operation to complete. Instead, it offloads that task and continues processing other requests. So once the I/O operation is finished, a callback function is executed to handle the result. So so when we start talking about a database, so we have to deal with network latency, right? So your application communicates with the MongoDB Atlas over the internet, right? The freeze, without asynchronous operations, the server freezes while waiting for the data. So the solution is Node.js is non-blocking. It initiates a request and continues working, handling the result only when it returns. A promise object, an IOU for future data. So a promise represents an eventual result of an asynchronous operation, such as a MongoDB call. But it could also be something besides that. It could be, even though we're creating an API, right, in our code itself, but sometimes, APIs could actually depend on other APIs, or, you could also need some kind of a file that you're grabbing, right? So them are also anything that's over the wire, so to speak. When I say over the wire, I mean over the network. So anything over the network, a promise is very useful for making sure that you can go ahead and successfully do asynchronous operations, right? And it's the core concept for managing operations that take time without blocking the execution of the rest of your program. You don't want to do it in a synchronous way. You want to be able. You don't want everything just to freeze up, right? You just want to keep on moving forward. So a promise can be in three different states. It can be in a pending state. So it could be in a pending state. So pending, the operation has started, but the result is not ready. It's also called the waiting state. Then also you have one of two things. It's either going to be fulfilled or it's going to be rejected. So if fulfilled, the operation completes successfully, and the promise now holds a value. The rejected, the operation failed due to network issues or other errors, and the promise holds an error object. Okay. So the important thing here about the promise is, remember, there's always three different states: pending, fulfilled, and rejected. And so you always going to be handling. You always have to handle both the success path and the rejected path. So mastering async and await syntax. So the golden rule: await only works inside async. So if you have an await, if you put an await and you don't have an async, the editor is going to let Visual Studio Code is going to let you know that that's not allowed. Okay. But the async keyword ensures that the function returns a promise. Okay. The await keyword pauses the function execution. It wraps the promise to reveal the actual data. Okay. So when we're doing our queries, right? So we're doing our queries from our database TypeScript file, you know, execution will halt in them scenarios, right? But when we're calling this find, like in this case is find all users here, when we're calling this from our API, from our different routes, at that point, when we make a call, okay, we can continue to do other things while that call's going on, okay? Once this call's done, right, it's going to return, right? It's going to return that promise, and then then we can use that data, okay? So basically, this is just showing what's wrong here. You're missing your await here, and since you are, the variable contains a promise object. Accessing users.0 will fail because the data hasn't arrived yet. The code kept running without waiting. So what happens? It'll populate this right away, right? But this call that you made takes a little bit, right? But when you do it like this on the wrong one here, it's actually going to set that to null. It's going to be empty, right? It's not going to have an object here that you're expecting, right? So this is the wrong way to do it, right? And like I said, if you had you need to make sure you use the await with the async, right? Over here on the right hand side is the correct way, right? So the variable contains this way. It will go ahead and have the correct data, right? Because it's going to it's going to do an await, and it's not going to populate this until the data comes back, right? But as far as execution, it doesn't stop executing at this line. You can continue doing other things while you're waiting for the data to be available. Okay. So here, we talk about the safety net, error handling with try catch, right? So data operations are risky. They can fail due to a lot of different reasons, okay? And every application is always going to have some kind of a failure for one reason or another. Just like some kind of network hiccup, the connection drops, maybe invalid data queries, something's wrong, right? So you always need to make sure you wrap all database calls within a route must be wrapped in a try-catch block. So the try-catch block contains the logic we want to execute. The try block, right? The catch block captures any errors, promise rejections or exception, and passes it to express. Okay, we need to talk a little bit more, and we're just going to actually kind of go into this just a little bit now, even though it says deep dive. So express routes, express routes are middleware functions, right? They have, we've already seen having, completed our previous labs about the request and response object that we have access to, right? But also there's this next as well. And so this next route can be used or based on errors. So it'll skip all other routes, right? It logs the errors and it'll sends a 500 response. Okay. So the result, the server stays alive. This is so everything don't freeze up on things. The client receives a proper error message instead of a timeout. Okay. But like I said, we'll look more into this when we get into some code. It's very important for you to make sure you pass the error to the global handler, right? And you do that using this next function that's available. Okay, the data translation, working with object IDs and type mismatch problem. So we know, like when we get URL parameters from, we've been testing Since we don't really have a real front end yet on our application, we've been using Postman to test things. So we all realize when you make a call from Postman and pass data, you're passing string data, right? Even if it's JSON data, you're passing strings, right? So Express has all these URL parameters. So like let's say that we did a bug ID, so we use an ID there, or a user ID. Well, that's going to be the string format, right? Well, for Mongo database storage, that was fine when we had our little in-person array. We just had that as a string as well, right? But for Mongo database storage, we have to use the BSON object IDs, right? So the risk is query failure. You cannot query ID with a raw string. It returns null. Object ID's construction has strict rules. The string must be exactly 24 hexadecimal characters. Passing an invalid strings, like 1, 2, 3, throws a BSON error, right? So it has to be 24 hexadecimal. But we can go ahead and, we can use a function to, when we generate new ones, right? You're not going to do that. You don't change the ID. The ID, once it's created, it stays that way. But it's only going to be when you do new things, right? You create a new document. Every time you create a new document, a new bug, a new user, you're going to have to generate a 24 hexadecimal character object ID. Okay. So we can kind of come up with this little new ID. So this is basically just an arrow function where you can use object ID.create hex string and pass in a string, and this will actually create a new hexadecimal, a new object ID for you that can be used when you're trying to, well, also it's used when you're looking for things as well, right? In this example down here at the bottom here, this code, let's say you're passing in a bug ID because you're wanting to query on that bug ID, right? If you want to just do a find one on that bug ID, you need to make sure that you're using the correct format, right? So it need to be in the object ID format. And so by using this little helper function here, then you make sure that's in the correct format, right? You just can't pass in a string for this ID and expect it to get the result. The standard route implementation pattern, a 5-step checklist for reliability. So first you're doing your data extraction. And so this doesn't matter if you're doing this from Postman. Eventually we'll have a user interface that will be grabbing this data from our UI, from the HTML in the browser using React. So first you'll have to do data extraction. So you either read, reading either the parameters or reading the request body. So that's our data extraction. Then we're going to be doing input data validation, which we've already kind of done a little bit, right? We check the required fields and we return 400 if it's a bad request or invalid. Then we go ahead, if it's valid, we go ahead and make our asynchronous call to our data using our database TypeScript file, right? And we use the await for our asynchronous call. From there, the fourth step is the logical response. So it's either going to send a 200 OK or with the data, or it's going to send a 404 not found, right? Then the fifth one is error catching. It's going to wrap in a try catch. So in case there is an error, we go ahead and grab that and we can go ahead and make decisions based on that error as well, okay? So here's just an example of the read operation for a get where we got a user ID. So obviously we extract our user ID, we call the find by user ID. Then if the result is null, we're going to send a 404. Else return a good response. Remember, good's always a 200 error, and we send back the JSON data, right? Otherwise, down here on the right-hand side in the code, right, if that doesn't happen, if there's we do a try catch during our try, if something causes an error, we're going to catch that and we're going to do the next error function. Like I said, we'll look into this in more detail going forward here. Here's just an example of a write operation in post. So you're extracting all the data from the body, in the case on the left-hand side here, basically like, in this case, an email or password for the register. We do a validation. If it's missing, we send a 400 back. Email's required. Okay. Otherwise, if it passes validation, right? And later on, we're going to use a validation framework. Right now, we're just doing some if statements, but we'll be doing some other validation. We're going to be doing a little bit more in-depth validation later on. But if it go ahead and passes validation, then we're going to check for duplicates, right? So like because it's going to be a little different. So somebody could have already registered. So we have to go ahead and check. So if we call the find by user by email, if that already exists, right? That means it's a duplicate, and we're going to send back a 400 error already registered. Else it doesn't exist, we're going to construct a new user object. We're going to write the await. We're going to write the insert user, okay? And then we're going to send back a 200 success response. So in the case for a register, it's going to be a little different. You're actually going to do two different calls. First, you're going to make a call to find out if that user is already there, right? If it already exists. So that's like the first thing we do before we don't want to just insert anything. First we have to see if there's a duplicate. We have to see if it already exists. So first we make the call to find out if it exists. If it doesn't exist, then we go ahead and create the new user object. And from there, we go ahead and insert the user. And if all works well, we send back the 200 error, right? I mean, the 200 response status code, which is a success status code. Okay, so next here, we're going to go ahead and start looking at some of the changes that we'll need to make our code, such as creating our database TypeScript file. So to get everything set up so you can access your issue tracker database via the MongoDB Atlas cluster. So I'm in my cluster right now. First thing I want to kind of go ahead and do is come down here and click on database and network access. And then when you come in here, you'll have your database username, whatever your database is, okay? On here on the left-hand side, you see this IP access list. Go ahead and click on that. You may already have an IP address in there, but for me to grade your homework, I need access to it. And sometimes actually the IP addresses can change. So sometimes if you, and especially if you're like, maybe it's somebody else's house and you're logged in on their internet, or you're like at the library or something else, right? Your IP address is going to be different. So if you ever try, it's happened to me multiple times. I'm somewhere, I'm not thinking about it. I try to get onto the database and I can't. It's because you have to add your IP address. One way to do it is to allow everything. And, from a security standpoint, that's not best. But for me, for grading purposes, just best for you to go ahead and do that. So what you'll need to do for that is click on Add IP Address and just click Allow Access from Anywhere. Okay, and it'll put in here and just hit Confirm. And this will set it up so it can your database can be accessed from anywhere. Okay, it takes a minute or two. It's in the pending state right here. I'm going to pause it, waiting for that. Okay, so that finished. That's active. So this is basically you can access your cluster from anywhere, your database from anywhere now. All right. So then the next thing we want to do here is we want to go back to our clusters here. And if, you know, I have some different ones, right? And yours might just be cluster 0. That's kind of the default, whatever. It doesn't matter. But, and hopefully you just have one, right? Go ahead and click on connect here. All right. And the next thing you want to do is come down here and this Mongo database or VS Code, just go ahead and click on that. All right. And you'll have a connection string. Okay. So this connection, we're going to put this connection string within our environment variables. Okay. So you can just copy this. The important thing is, and I'll mention this, is a DB string. This whole part, including the brackets, you need to put your password in, right? So, and that's your database password. You know, you have a couple different passwords. You have a password to log in to the Atlas, and then you have your database password, right? And that can be different. That will be different unless you use the same one. Okay. So I'm going to go into Visual Studio Code now. So in your .env file, right, you probably should have what the same thing I have here is a debug for the app. That's for your debug statements, and then your port. And then here you want to go ahead and do db, right, underscore URL equals, and then probably should put this in quotes. I think you can be fine without it. I always put it in quotes though. Let me make sure that it's all in one line here. I think it is. So there's that. So the thing you're going to have to replace here is this part right here, right? You're going to replace that part right there with your password, okay? So you need to go, you know, and that's your database password, all right? And the other thing I want to mention is we're going to put something behind our URL here. We're going to put some additional information here, and I'm going to explain to you what that is here. Okay, so I'm also going to add this as well, and I'll explain to you what this means. Rewrites equals true. So in a distributed database, a temporary network glitch or there's other reasons could happen as well, can cause a write operation to fail. So without setting this, your application would throw an error, and you'd have to, you know, kind of actually write complex logic to retry it and stuff like that. So if you include this, though, if the write fails due to, you know, a retriable error, like a network glitch or something, the database driver automatically attempts operation one more time. Okay, so it'll go ahead and, if it fails once, it'll go ahead and retry it again, right? So it kind of prevents you from, and because there's always glitches now and then, right? So it kind of prevents you from, at least it's going to try another time, okay? Obviously, if it tries another time and fails, that's another thing. But, you know, at least this kind of reduces the amount of issues you can have with some kind of a network glitch, okay? The other part here is W equals majority. And so the W actually stands for write, and it dictates how many nodes in your cluster must acknowledge the write before the database tells you the app is successful. So if you had write equals and just the number 1 here instead of majority, that's actually a lot faster, okay? But, you know, we're more concerned, we're not more worried about speed as much as we're concerned about durability. So if you use majority, though, it's slightly slower, right? But it's a lot more reliable. It'll try, you know, more of the cluster, more of the nodes before confirming. Okay, it's just how MongoDB writes things out to a database. It uses these nodes. Okay, this is kind of behind the scenes. You don't really have to worry about it, but it uses these. And when I say nodes, I'm not talking about Node.js. I'm just talking about nodes. as far as from a database perspective. And so MongoDB writes to these nodes, and once it writes to multiple nodes, more than one, right? Then it will go ahead and return that it's good, right? And you can move on. If you just had a W equals 1, as long as it writes to 1, it's finished and it moves on. So, okay, you don't have to really worry about it too much, but like I said, make sure that you got your forward slash. So all of this, you got this right from Atlas, right? And then all you're adding on is this part right here, right? And like I said, make sure that you update this with your password, okay? With your and that is your database password to your specific database. Okay, the next thing here is you want to add your database name. For that, you want to go to Compass and click on Connect. And just make sure, see mine is called, depends on what you call it yours, right? So hopefully you should have, was part of an assignment, when you did the schema, you created some data. If you need to create some more data, that's fine, or start over, that's fine as well. You can always do that. But I have some bugs here. I got a few bugs and I got a few users, and you should have the same, right? But the name of my database, right, is issue tracker _. So that's what I'm going to use in the environment variable. Okay, and then so these two variables, the DB URL and DB name, these will be accessed within our database TypeScript file. Make sure, like I said, yours may be a little bit different, but so make sure it is what you have, whatever you call the database, make sure that you use the correct name. Now I want to look at the database TypeScript file. So the important things to do here is make sure that you import the Mongo client, right? Let me go look at the lab assignment real quick just to make sure I'm pretty close to being in sync with that. So so we already did this update the environment part, right? The environment variables. And then add the database module. So yep, you need to add this new file, database.ts, and you can copy what's in here. And so this will give you a little bit of a head start. Now what I did here is I moved because I know that you created the interfaces, I believe, in your routes. So you kind of want to move them over into this database file. That way you can do all of this over here, okay? So move those interfaces over here. And if you call things a little differently than what is in here, okay, it doesn't have to be exactly like this. And if you've got, this is just kind of my suggested, but you do things however you want to do it. It's fine. But some things are very important, as far as from assignment perspective, you're going to have to, you're going to have the title and the description, steps to reproduce, but you may have named things a little bit differently, right? Obviously you're going to have to do a classification, a lot of these things you're going to need to do no matter what, and you're going to still add some things to this as well. As if you recall kind of the ERD, when we did that, I had the comments and the test cases and that, but that really isn't really necessarily part of this assignment, so I kind of don't have that included at this point. I kind of have that little bare bones right here, just for what we need for this assignment. Now, as far as our calls here, this looks good. And I'll go through this real quickly here. In the code itself, a little easier than maybe here. So, we're basically parsing an ID. Okay. All right, let me just go back to the code. I just want to make sure that looks good. And yeah, watch out in here. It might be on two different pages or multiple. It's actually on a few different pages there. All right. So let's look at this line right here. So this is basically creating a object ID out of a string, that 24 character hex string, right? Has to be in the object ID format. So this would come from, so when you do whenever you insert a new record, it's automatically going to create an ID, right? It's only going to really be necessary when you're, doing lookups and things like that, right? You need it to be an object ID, not a string ID. So let's just say when you do the get user by ID, from Postman or from a front end HTML page, GUI, you're gonna be passing a string in, right? So you'll have that string, but you're gonna have to take that string, convert that into an object ID, okay? And then you can use that to query. So if I kind of come down here real quick, at a couple here, I'm not going to show you all of these because you're going to be creating these yourself. But down here, you can see on line 67 right here, I've got an ID, a new ID. So this will put that object ID in there, okay? So when you do a find, when you call this and you try to do it based on your collection, right? It will go ahead and find that because you have it in the right format, okay? So that's where new ID is used. So the place you'll be using that will be both, when you're like find user by ID, find bug ID, updating a bug or updating a user, or deleting a bug or deleting a user, right? All of those cases, you're going to need that ID. You're going to have to convert that string into a Mongo object ID. So this line here is actually, it's a global variable for storing the open connection. You don't use this kind of directly within your code down here. It is, used based on your connecting right here, right? The way this kind of works, that it's kind of a cache, right? So initially there'll be no connection, so it'll be null, okay? Once connected, it will hold the database instance. And that whole underscore thing, that's kind of a naming convention suggesting that this variable is private and should only be accessed via the connect function, right? So you shouldn't be accessing this directly, right? You should only access this via the connect connection, okay? As you can see down here, we're doing the connect right there, okay? So you won't be accessed, so this is only within here. So here the connect thing is, this is kind of using what's called the singleton pattern. Some of you might have know of this already from the .NET class, the second year class. But it's a singleton pattern. So what it's going to do, it's going to check to see if you already have a connection. If you do, it's going to skip that setup and it just returns the existing one. Otherwise, it's going to create a new one. But the singleton pattern is all about, because if it's already exists, you don't want to do anything. You can, once a connection's made, you don't necessarily have to reconnect every time, right? Even though you're asking this to connect, it doesn't really, once you connect it once, as long as nothing happens to cause that connection to close, right? Then it's going to stay connected. So you could do multiple functions, right, with the same connection. If for some reason the connection fails or gets closed for some reason, or whatever, then it'll every time you call this, it's going to come into this function, And then if it's not, this doesn't, if this is not connected, then it's going to go ahead and get that connected and set that up. So here's just a ping. This is very common. Connects to the data, verifies the connection. So once you start it up, you ping it. So that way, starting up a server, you can say, oh, yeah, we're good. You don't want to, it's kind of a good idea. Now, there can be issues with ping and Google Cloud. So I may come back and tell you that before, you may use this while you're developing, but we may have to kind of comment this out when we push this to Google Cloud. I need to verify, things do change with Google Cloud and that. And, but I do believe that this cannot be here because I think that this will cause a problem. Because Google Cloud uses using like Cloud Run under the hood. It's using like Cloud Run, and it's a serverless, and so it doesn't like you don't. Basically, with serverless, it's only if something connects to it. I don't want to say connects to it. If somebody hits that URL, right, it'll kind of wake, especially if it sits for a while. So let's say you deploy your thing, you click on it. Usually the first time it's a little slower, right? Because then it like starts it up, so to speak, in a way. And then once it's there, you can use it. If you're using it. Now I'm talking about via the cloud, right? Via the URL in the cloud, Google Cloud. And then you could actually be using it for a while. But if it sits dormant for a little while, it's not like active. It's like inactive, but it's there. And let's just say 24 hours later, you click it again, and it's going to be slower that first time again because it's like reactivating. It's like waking it up again, right? And with that in mind, what happens with pings, they don't want for like Cloud Run things and that serverless stuff. They don't want those pings going on all the time like that. Okay, from the app itself. So they tend to not like that. So, but I'll let you know on that ping. All right. Now let's look at a couple of these functions here. Let's look at find all users and find users by ID. Okay. Let's look at what's kind of different here, right? So we're using async and await. We talked about that. So we use both. We're using await twice, one for the connection and one for our query, right? So in here, it's telling you can understand right here. Well, you're using a promise, right? Because we already talked about promises at the beginning. So it's using a promise, and it's a user array, right? So that's going to be different for my ID. We're not using a user array, right? We're not using a user array. The next thing I want to kind of mention here, so you have to write it kind of in this fashion. It's a little bit different than what we've done for, those standalone queries from the MongoDB, like we're using in the shell, right? But it's very close, very close. So you got db.collection, and in your collection, this will be your collection. So if you called your collection user instead of users, then it's going to need to be different here, right? Because that's kind of a common thing I've seen, students doing incorrectly. You got to make sure you're calling the right thing, right? So if you don't have a collection called users, this ain't going to work, right? So this is where you define that. And obviously we're using types. So it's we're using types. So it's a user type. Let's see. And for what we're doing for a find all users, we need an array, right? It's going to be, it could be a document of one user if you only have one, but for the most part, we're talking about usually you're going to have more than one, right? So you're always bring it back. So if there's only one, it's going to bring back an array of one item, right? Otherwise, it's going to bring back multiple, right? So this users here is going to be an array of users. as opposed to by ID, it's just going to be one of them, right? Let's see, anything else I want to mention here? Like I already said earlier, we got the do ID here. We're getting the user by ID. So when we bring this in, this is going to be a string coming. Let's see, user ID is going to be a string that's being passed in. So these are being called from where? They're being called from your routes, right? So both of these are being called from the user route. And so you're passing in a user ID of string, right? Because that's what in Postman or from your front end, that's what you're going to have. You'll have access to that user ID. So you'll be passing that in, and you need to convert that into an object ID. Now, another important thing is to remember that for every function that you create in here that you need to call from somewhere else, you have to define this within your file. So I've got an export here. Now you're not going to have all of these yet, right? I have, you're going to do one at a time here, right? You're going to do one at a time, and you don't want to put something here that doesn't exist, right? So that's going to be a problem as well. So once it exists and you've created it, then you can include it in the list here, right? And then from your user route, well, I'm going to look at user routes. Same thing would be the same thing for bug routes as well. For user routes, what you're going to be doing here is what things are you going to need from there? Well, here actually I'm importing my user interface, my user as well. That's your interface there. Let's see. And then, here's the different ones that you would be importing. And like I said, same thing here. If you don't have it created yet, you can't import something right? So at the beginning, you're going to start with one at a time, right? Find all users. You don't want to start writing a whole bunch of them. You become a mess, right? Get one working and then continue from there, right? So this is how you do that as well, okay? Let's see here. What else I want to mention? Okay. So basically, this is how you call that from within your route. So you're calling find all users, which was defined in your database.ts file. Once this is this is within a try catch, okay? So if there's an error, it's going to go ahead and come all the way down to here. If not, it'll populate that user stuff, right? And it will, return the JSON right here, right in front of me. JSON, so it'll return the JSON if it finds it, and all's good there, right? And then here's for user IDs, a little bit more to do here. So same thing, request or response in this next function as well, right? Here you've got your string ID, right? So here you're looking for a user with that ID, just got a debug statement, right? You're passing in a string. As a string, you're passing this in. Then on the database side, in the database TypeScript file, that is where you're converting that to an object ID to be used with MongoDB, right? And here you're checking if it is a user. If it's not a user, go ahead and say the user is not found. Otherwise, return your user as JSON data. Okay, hopefully that's not too bad for you. So, very similar for the bug stuff. At least, some of those initial routes where you're listing the bugs, you're getting the bug, right? Pretty much the same thing, right? Obviously, you're just going to have different methods. You're using a different collection, right? You're using the bugs collection. but everything else is pretty similar. It's almost in a way, it's almost a duplicate, right? Except your route's different, and everything's bug instead of user. But everything else is pretty much a similar thing. So the first two, if you try to get those working first, your user list and your user ID and your bug list and your bug ID, and so them should be the easiest ones to get working there. So next, you want to go ahead and get a terminal up and running. And let me see here. You want to make sure you install MongoDB. Okay. And since you're working on your different TypeScript files, remember always to build that, right? Just out of habit, it's probably a good idea to always build that. So I'm going to run npm run build. Make sure you're in the right directory structure. It's easy to get confused between the front end and the main one, the root. And from there, we can start up our server here. npm run start. Let's see if everything works. So there we go, connected to the database ping, so success. So database connections verified, you're good to go. If you have a problem here, you did something wrong, so right? So you need to make sure that you've got things set up in your environment variables correctly. You've got your password on there in there. You're using that right URL string, the Mongo database one we got from Atlas. So you need to make sure that you did that correctly. You have like I said, you have your password in there, and you have the correct name of your database, and you have data in your database, right? You need data as well. You don't need data to access it, but you need data to do anything besides that. So let me, real quick here, I'm just going to bring up Mongo, Postman, not Mongo, bring up Postman, right? And let's see what I'm going to do here. I think I should have some stuff from before. So I'm going to run this. And let me see why I didn't get any data here. I think I just discovered what was wrong. I had a hyphen here instead of underscore. All those little things, right? It has to be perfect. Let me go ahead and let me go back and restart my server again. Control C to kill it. Do CLS to clear my screen. And let's go ahead and do start again. See, it access, it access my cluster. The database connection just kind of access it, right? Can access the cluster. What database you use, that's a whole different thing, right? All right, let's try this again. So I think my API looks good here. My path looks good. Let's try this again, and there's my data, right? So let's go ahead and update one. Let's see what I have here. Well, let me just do it by ID. So you're not going to have all this anyhow. Send, and so it's getting it from the ID, so it's grabbing all this from the database, right? Now, eventually, you're going to have some other ones as well, right? So we're going to do, let's see, update by user ID. I think I update Jones to 3. Let's change it to 4. Let me go see what we've got in our database on that. Make sure, pull that up here real quick. So we got Jones 3 here, right? I put family name Jones 3. That's what it's currently. I'm changing that to 4. Let me come back to Postman here. And hit send here. User updated successfully. We go back to the compass, and if I hit the refresh, there's a refresh up here. So if you're out here, this ain't gonna update on its own. You got to refresh it. You come up here on the right hand side. There's a little refresh thing. Click it, and then now it says Jones 4. So it's connecting to the database, bringing the data back, updating data, etc. Okay. Some other things I'm going to do here. You know, it's always good to have your log messages in here. You can see everything that's going on. That's very important. It's nice. It uses different colors for the different ones. So a couple other things I want to do, I'm going to go over, and I'm just going to do a separate video on that. I'm going to spend a little time understanding this next function and how this really works. And that's one thing. And the other thing I wanted to also do is setting up debugging. So you can come in here, you can you can actually use the debugger to walk through the code, put breakpoints and everything else, right? So I'm going to show you the steps to set that up, because that's going to be very useful going forward. And when you start running into some problems here and there, you can use the debugger to figure out what's wrong. So that's all I have for this video. Please let me know if you have any questions, and have a great day. Thanks.